Hi everyone, for today's lesson we are going to start Unit 4 and we are going to discuss polygons and the triangle sum theorems. Our learning targets for today are for you to be able to say, I can classify triangles. So classify means that you're going to put them into a category. Classify triangles by their sides and their angles. And I want you to be able to say, I can explain the triangle sum theorem. There's going to be a few theorems that we are going to be discussing dealing with the triangle sum theorem. So there's a couple of them that are piggyback off of them, or off of that idea. So our lesson for today, you're going to need the following. You will need a glue stick, you will need colors, something to write with, and you will need all of the following cutouts. So the Unit 4 Day 1 cutouts had a lot of cutouts with them. So we are going to go pretty much in order of the cutouts, starting with the names of polygons. And then we're going to talk about definitions of interior and exterior angles. Then we're going to be working with classifying triangles by their sides and their angles. The next one that we are going to be using is the triangle interior angle sum theorem. Then we will work with the smaller triangle that's not a right triangle. Then we will work with the right triangle that's a little bit taller. And finally, I have a joke for you. So these are all of our cutouts for today's lesson. Let's go ahead and get started with polygons. We're going to start transitioning into talking about other polygons, with this unit primarily being about triangles. But I want you guys to have all of the polygons named in one spot for you, because we are going to be working with them just a little bit, getting started in this unit. So polygons are just shapes that have different corners and different sides. And the different types of polygons that we have start with our three-sided figures, which are called triangles. Four-sided figures are called quadrilaterals. Five-sided figures are called pentagons. Six-sided figures are called hexagons. Seven sides are called heptagons. If it has 8 sides, we call it an octagon. If it has 9 sides, we call it a nonagon. 10 sides, we call it a decagon, like decade. There are 10 years in a decade. 11 doesn't have a name. We call it just an 11gon. 12 is called a decagon, and anything after 12 is called an n-gon, where it has n number of sides. So if we're talking about a figure that has 15 sides, we would call that a 15gon. And this is just an introduction into all of the names of polygons. The primary ones that we are going to be studying are in this unit is a triangle. We will be proving triangles congruent, but we will also have some other problems that will have quadrilaterals, pentagons, and maybe even hexagons in it. We start diving deeper into a lot of these other shapes later on into other units, but I wanted you guys just to at least have an idea of what these names of polygons are. The next thing that I want you guys to take out is this vocabulary sheet, and that is over talking about triangles, not necessarily just triangles, but we're referring to triangles in this figure. And we're going to talk about things called interior angles versus exterior angles. So go ahead and glue this directly into your notebook. And the first vocabulary word that we have is interior angles. And when angles are inside of a triangle, or any shape for that matter, those angles are called the interior angles. And the interior angles are like the angles that you see here, angle 1, angle 2, and angle 3. These angles are located inside of the shape, and we call those interior angles. Angle 1, angle 2, and angle 3. They are known as interiors. exterior angles, or when the sides of the polygon are extended. So as you guys can see here, the sides have been extended. When they're extended, there exists other angles that are formed on the outside of the angle. These are known as exterior angles. Our exterior angles in this case are like angle 4, angle 5, and angle 6. They're located outside of our figure. And the thing that I want you guys to recognize about interior and exterior angles is that these angles form linear pairs with the interior angles. So whenever you see interior and exterior angles, know that they form linear pairs. Like this angle right here matches up with angle 5. Angle 2 and angle 5, they form a linear pair. Together, they form a line. Same thing if we were to talk about angle 6. Angle 1 and angle 6, this interior angle and this exterior angle together form a line. They are a linear pair. So the thing that I want you guys to know about interior and exterior angles is that they form a linear pair. And we can conclude that the measure of an interior angle plus the measure of an exterior angle, where the interior and the exterior angles form a linear pair, we can say that they would add to equal 180 degrees. So when an interior angle and an exterior angle together form a linear pair, we can say that they are supplementary and they will add to equal 180 degrees. And that's going to be something that we are going to not only use, but we are going to be working with whenever we're solving algebraic equations. The next thing I want to make sure I talk to you guys about are classifying triangles by their sides and their angles. So let's go ahead and take out these two different boxes. The first one being classifying triangles by their sides, and the other one is classifying triangles by their angles. Let's go ahead and paste them in. There's classifying by their sides, and then classifying by their angles. Classifying by their sides. We have three different types of triangles that can be classified looking at and analyzing the sides. The first type is called scalene. And what scalene means is that you have a triangle with three different sides. That means that all of the side lengths are different, and there are no congruent sides, 0 congruent sides. Those are considered scalene triangles. Isosceles triangles means that you're going to see that at least 2 of the sides are considered congruent. You'll notice that they have the same tick marks. And what's really cool about isosceles triangles is that the base angles, the angles that are across from the sides that are congruent, the base angles are also congruent. The other angle will not be the same. So that's kind of a cool thing about isosceles triangles. Going back to scalene, not just are all of the sides different, but all of the angle measures are going to be different as well. So in scalene triangles, you'll have no congruent angles. In isosceles triangles, you'll have 2 congruent angles, and they will be opposite of the sides that are congruent. Opposite meaning that they don't really touch the opposite side. And finally, we have equilateral. And an equilateral triangle is a triangle that has 3 congruent sides. all of the sides are congruent. And what's really cool is that following along with scalene and isosceles, an equilateral triangle has 3 angles that are congruent as well. So equilateral are also known as equiangular. And I'm going to write that down in just a second. So these are our 3 different types of triangles that we can classify by their sides. The next type of triangles that we can classify are classifying triangles by their angles. The first one is acute. And what's cool about acute triangles is that all of the angle measures are acute angles. They're not necessarily all different angles, but all of these angles are going to be less than 90 degrees. So there are 3 acute angles in an acute triangle, and every single angle is less than 90 degrees. Every single one of them are. In a right triangle, what you're going to notice is that one of the angles is a right angle. The other 2 angles are going to be acute angles. They might not necessarily be the same. They can be the same, but the other 2 are going to be acute angles. And they have a special relationship that we're going to talk about a little bit later in this lesson. But there is absolutely one right angle. If you see a right angle, we call that a right triangle. The next type of triangle is known as an obtuse triangle. And what you're going to see is that one of the angles will be bigger than 90 degrees. And if you see that one of the angles is bigger than 90 degrees, we call that an obtuse triangle. The other angles are going to be acute angles. They will not be right. If we had a right angle, we would call it a right triangle. We would never see this being a right angle. And then finally, we have equiangular. An equiangular has 3 congruent angles. And if we know that all of the angles of a triangle add up to 180 degrees, all of these angles are 60 degrees. Because they are all equal to each other. And we know that if we have all angles that are equal, what's really cool is that all of the sides are equal as well. So in an equiangular triangle, all angles are going to be 60 degrees. And the way that I got that is I went 180 degrees divided by 3 is equal to 60 because all of the angles are congruent to each other. The other thing that I want to talk about when it comes to equiangular and equilateral, if any polygon that is equiangular is also equilateral. And if a polygon is both equiangular meaning that it has this equal angles, every single angle has the same exact measure, and it is also equilateral, any polygon that is both equiangular and equilateral, we call those regular polygons. Regular meaning the sides are congruent and the angles are congruent to each other. We call it regular. And we are going to be working with that word regular a lot, especially as we get into other units. We'll be talking about what it means to be regular. Regular polygon. So any polygon that is both equiangular is also equilateral. And equiangular and equilateral means that it's called a regular, which sounds very ordinary, but a regular polygon. All right, I have to go ahead and flip the page. Next, I would like you guys to please go ahead and take out the triangle sum theorem and go ahead and paste that into the very top of your paper. This is the triangle sum theorem, and I've already talked about it a little bit in this lesson already. And the triangle interior angle sum theorem, notice I'm using the word interior angles because now I have to classify, am I talking about interior or exterior? But the sum, meaning if you add all of the angles of the measures of the interior angles of a triangle. So the sum of the measures of the interior angles of a triangle is 180 degrees, always. So that means that the measure of angle A plus whatever the measure of angle B is, plus whatever the measure of angle C is automatically 180 degrees. And I know that we've talked about this before, but now it is official. I have taught it to you. All of the angles of a triangle add to 180 degrees. And now what we're going to do is we're going to extend that to the next level. And what we're going to do now is talk about the exterior angle theorem. So we know about the interior angle theorem. This is our foundation. But the exterior angle theorem, remember we're talking about angles that are on the outside. If we were to extend out all of the sides of a triangle, goes like this. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. The two non-adjacent interior angles. So the measure of an exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. So what does that look like? So what I want you guys to do is I want you to draw a picture of a triangle. Any triangle is perfectly fine, and I want you to extend one of the sides. And I would like you to please label this triangle A, B, and C, and we're going to label this exterior angle number 1. So let's go ahead and analyze this theorem. It is the measure of the exterior angle, which in this case is going to be the measure of angle 1. The measure of angle 1 is equal to the sum of the measures of the two non-adjacent interior angles. So the angle that is adjacent, is angle C. And that's because together, angle 1 and this angle C would form a linear pair. They would add to equal 180. But this is also, we know that the measure of angle C plus the measure of angle A and the measure of angle B also equal 180. So what this theorem is saying is that the measure of angle 1 has to be equal to the sum of the measures of the two non-adjacent interior angles. It's equal to the measure of angle A plus the measure of angle B. This is using the substitution property to the next level. That is the exterior angle theorem. I want you to think about this. If we know that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180, and we know that the measure of angle 1 plus the measure of angle C, which what I mean by angle C is this angle right here, is equal to 180 degrees. What we can do is we can set these two equal to each other and say that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to the measure of angle 1 plus the measure of angle C. We know that because they're both equal to 180 degrees. So we can say that these two expressions are equivalent to each other. We know this because angle A, angle B, and angle C, we're using the triangle sum theorem. And we know measure of angle 1 plus this measure of angle C over here. They are a linear pair, and they would add to equal 180. So therefore, these two expressions are equal to each other. And if you were to subtract away the measure of angle C from both sides, what you're going to find is that the measure of angle A plus the measure of angle B has to equal the measure of angle 1. And that right there is the exterior angle theorem and why it works. So this is kind of like a mini proof, kind of explaining it. And even if that's not enough, what I would like you guys to please do is please go ahead and take out the triangle that is not a right triangle. So we had two triangles here, one that is really tall and the other one that's not tall. I want you guys to use the one that's not tall. And what I would like you guys to please do at this time is I would like you to please go ahead and label the angles. Label it angle 1, angle 2, and angle 3. And I would like you guys to please go ahead and trace this triangle into your notebook. So please go ahead and trace it to the very best of your ability. We are tracing. So that you can see these angles. And I would label just like you did before. Here's angle 1, here's angle 2, and here's angle 3. And also to the best of your ability, please extend out angle 3 just a little bit further. So what we did is we traced this triangle, we labeled it the exact same way as the triangle that I have here, and we extended out the line so that we created an angle. And what I want you guys to do right now is I want you to pinch and rip just angle 1 and pinch and rip angle 2. Make sure that you still have a little bit of a side, and what I would like you to do is please go ahead and paste the remainder of this triangle into your notebook. So I'm going to flip it over and paste. And so now you have these angles. Don't get rid of them. I want you to label angle 1 on the other side as well and label this angle 2. as well. So labeling it on both sides. So it has angle 1 on both sides and angle 2 on both sides. And what I want you guys to do is I want you to match up your angles on the other side. And what you're going to see is that collectively, angle 2, angle 1, and angle 3, when you add them all together, they end up equaling 180 degrees. And angle 1 and angle 2 will match up perfectly in that exterior angle position. And that shows that angle 1 plus angle 2, when added together, will equal the exterior angle. So we can say that the measure of angle 1 plus the measure of angle 2 add to equal the measure of this exterior angle. And that is a demonstration of the exterior angle theorem. We have just one more thing to talk about. I have to flip the page, so I want you guys just to be aware of that. We have one more topic to talk about, and that is a corollary. Now, a corollary that is a corollary to a theorem. Is a statement that can be proved. Easily using the theorem. The corollary is a more specific case of the theorem. So a corollary to a theorem is a statement that can be proved easily using the theorem. A corollary is a more specific case of the theorem. So what we're going to do is we're going to talk about the corollary to the triangle sum theorem. So the corollary to the triangle sum theorem deals with right triangles. So this is a corollary to the right triangle. To the triangle sum theorem. So we're going to be talking about a more specific case, and that more specific case deals with right triangles. This is true for all right triangles. And it goes like this. The acute angles, so it's a statement, the acute angles of a right triangle are always complementary. And remember what complementary means. Complementary means that they add to 90 degrees. So this corollary to the triangle sum theorem says we know that all of the angles of a triangle add to 180. But if we're just looking at right triangles, the acute angles of a right triangle, so it must be a right triangle, are complementary, which means that they add to 90 degrees. So if you were to draw a really quick right triangle, and we were to label this triangle A, B, and C, we would say that the measure of angle A, which is one of our acute angles, plus the measure of angle B must equal 90 degrees, which in other words is the measure of angle C, which is the 90-degree angle. This only works if we are dealing with right triangles. So if you wouldn't mind taking out our last triangle, what we are going to do is I would like you guys to please, to the very best of your ability, trace, once again, this triangle into your notebook. So somewhere into your notebook, please go ahead and trace this triangle. And just like before, I would like you guys to please go ahead and mark up the right angle. So in this case, I'm going to mark up this right angle, and I'm going to label on both sides angle 1 and angle 2. And I'm going to mark up inside of here, and I'm going to label this angle 1 and angle 2 on my paper. And I'm going to flip it over on the other side and match up angle 1 with angle 1. And I'm going to match up angle 2 with angle 2 so that I have it on both sides. Angle 1 matches, angle 2 matches, and I'll even draw in my right angle. So I have it matching on both sides. And just like before, I would like you guys to please go ahead and pinch and rip angle 1 off and pinch and rip angle 2 off, just enough so that you have the angle detached. And then just like before, I would like you guys to please go ahead and paste the remainder of this triangle back onto your drawing. So you want to make sure that you're pasting it to the very best of your ability back onto your triangle. And what I would like you guys to please do is please go ahead and manipulate the angles so that they match up and together add to equal 90 degrees. And what you can see here is that together, angle 1 and angle 2 perfectly match up with our right angle. And that indicates that the measure of angle 1 plus the measure of angle 2 add to equal 90 degrees. So I'm going to paste these angles right on top of that right angle. Which is so cool that it just works out that way. And this is a cool demonstration just to prove that these theorems and corollaries, we're not just making them up. They actually work, which is so neat. And I'm going to write down on the side that the measure of angle 1 plus the measure of angle 2 add to equal that 90-degree angle. So I'm just going to mark up this 90-degree angle on the outside, which is so cool. And that is a corollary to our triangle sum theorem. And now I have a joke for you guys, and if you wouldn't mind pasting this joke right in on the side, because why not end this lesson off with a joke? And that joke is super cute. And what it says is it's called a new dating angle. And in it, it reads, "Hi, you're a cute angle. Thanks for the compliment." And that's because these angles are complements of each other. Oh, you gotta love math humor. That is the end of today's lesson. If you guys have any questions over anything I just showed you, please feel free to email me. Otherwise, I hope you have a wonderful day.